Hey Jawad, good morning.
Hey JP, how are you?
I am good, Jawad. How are you?
Doing well? So sorry I couldn't join either last week.
Yeah, no worries. Actually, hope you had a good break.
I did. So I hear that there was some discussion on the golden chip, right?
Correct. Yeah, Golden Chiplet and Kash presented, and looks like Mark also joined. Hi, Mark. Morning.
Hello. Hi.
Yeah, so Kash presented, and what I mean, looks like they are developing this the chiplet for FPGA applications, and this could be used as a golden chiplet, and is looking for some kind of OCP support, either to fabricate it in the global foundries. Right, they're using a GF22 or process, and he's looking for some kind of support for that OCP support, in kind or cash. I think it's mostly in kind is what is expecting, and then the substrate, right? And yeah, he didn't come up with a budget, but broadly he outlined it.
Okay.
Yeah, so I requested him to actually present this to wider audience in the 8 a.m. call Friday, to gather more support, and I think he's probably is going to reach out to UCE folks as well to garner more support. Yeah, that's where we stand, Jawad, and I don't know if Akash is going to join today, but yeah, we need companies working on the chiplets to actually agree on and at least support this effort, if not fund.
Right. So JP, this morning in the sub-project call,
Uh-huh.
we had Deca Technologies.
Oh,
They
I missed it. Okay. Uh-huh.
they you can look at the recording,
Okay.
but uh they have the same constraint, which is you need to have budget to access their their technology, right?
I see. Okay.
So it's basically the same thing, and they now do have access for prototyping through Arizona State University.
Hmm.
So it's possible that if we can have some kind of a support available from some commercial companies, that we could potentially make use of DECA technology and their association with ASU. We can also potentially directly work with ASU.
What does AAC bring to the table, Jawad?
So Arizona State University has received a lot of funding from US government theoretically
Uh-huh.
to build prototyping lines. Okay, so in theory, groups like us who need a proof of concept prototyping, in spirit, Arizona State University should be able to help us with that. But again, all of these government programs are government-private partnerships, right? So even access to ASU will not be free, right? It will have to be deeply thought through, but at least there is an option.
I see. So they have what substrate fabrication or what fabrication they do?
So that's a good question. I was thinking maybe one of these days we should actually invite them as well.
Hmm.
But they are supposed to do both substrate and assembly.
Oh, I see. Mm.
In
They can
fact,
do assembly as well. Okay, interesting.
yeah, in fact, if I'm not wrong, they received $100 million grant to develop substrates. Yeah, it's a university got that kind of grant. Yeah.
I see. It'll be definitely good to understand, even if they expect funding to develop something. But at least we want to understand the research and directions what they're doing.
Yeah.
So, right? Do you have any contacts, Jawad, so we can bring them in for the one of the meetings?
Yeah. So I know the professor who was the main guy.
Uh-huh.
So I'll reach out to him and ask um, if there is, what may be the best way to engage. But nonetheless, JP, it's the same theme. The theme is there ought to be support or need from broader industry, and to the point that people are willing to spend at least some money to pay the NRE costs, right?
Right. Yeah, that would be the challenge in the POC. Right. I think
Right.
other groups are focusing on more on the standards and specifications. It may be a lot easier, but POC would be we would face challenges like this.
Right. So I know we have this one concept of um, the golden chip, which is for die to die,
Mhm.
right? And that requires some deeper thinking and consultation with OCP to see if a project that is pretty high in potential budget, what is it that OCP willing to help with?
Right, yeah.
Right. The other one is, this project that David showed us, right, which is mostly software-based POCs, right?
Hmm.
Right. And right now the focus is mostly for CDX, the focus is mostly on EDA workflows, right? But not actual design and design engineering challenges, right? Or maybe even simulation challenges.
Hmm. Yeah, I think definitely that's a good track, Jawad, because we can pursue this, and then when there is sufficient interest for POC, we can convert that into an actual implementation. But I think that there we can make lot more progress, and something we can pull in community as well.
Right. So that's the other one. And uh, beyond that, uh, you have that some of the designs done in the past. I'm not sure if that is something that is a potential variant that we want to look at. But after looking at, all the things in last few weeks,
Hmm.
these are the three on my list that have the potential and for us to think through and see where do we focus our energy, and maybe we should just go after all three of them. So, I know we're only four of us here today, but let's just think through this a little bit and talk through it.
Sorry, Jawad, I've been talking to a muted mic for a while. So yeah, so for the golden chiplet, we like the Kaj proposal, we like to understand maybe they have something in there already, right? So we can use that as a starting pitch and saying, hey, this is actually already available. What OCP can contribute to it? That might be a kind of good lead in. Um, right? But I'm more optimistic about that what David was showing, um, because that does not involve any funding or anything like that. We can make progress. And what do you think, David? Do you have any suggestions?
Yeah, definitely. We can do a I'll call it a virtual POC,
Okay.
right? To demonstrate, hey, here's what the possibilities are, right? What the virtual possibilities are, and how do we make a physical reality? The same way, my expectation is the same way. Everybody got excited about the work we're doing. That may, I'm thinking that the virtual POC may spark an interest for somebody to do a physical POC, right? And, you know, to the point where we may get some funding.
Right, right, right. Certainly. Um,
And if somebody has already a golden chiplet, we can work even with that, right? To say, hey, here's a couple of virtual technologies, how this would look if this was a real implementation, and go from there.
Yeah, definitely. That sounds very appealing, David. At least what we can do is we can start with workflows, certain workflows demonstrations. We can actually include this, correct? For instance, we talked about earlier about the IO verification, right? And then the CDX specs automation. If something is specified in CDX automation, I don't know if it's already you are doing that, but those are things in my mind.
Yeah, exactly. I'm kind of thinking the same thing.
Okay, okay.
Right, there's anyway, right? A lot of the chiplet stuff is there's a lot of ugly data and exploration that needs to happen, right? And that's where the CDX workflow come in. So if we can demonstrate, hey, we can do the early exploration, might be easy, more interesting for somebody to fund and see that in reality this will come to fruition, kind of whatever we predicted, it will still work the same way if it was implemented, right? Or if somebody has different technologies that we can work on in terms of substrate and stuff like that, right? We can see how that looks. So yeah, I think definitely makes sense to have the software and the workflow kind of lead the way. I don't mind doing the work anyway. We're gonna do something. So if it's actually the way I think about it. It's probably good for us to start with something a little bit more focused in terms of exactly what the workflow is trying to achieve, rather than us coming up with chiplets just to demonstrate the workflow. Right? It makes our demo also more realistic.
I see. I see. That sounds certainly interesting, David. So maybe can you actually give a high level overview of what is the status of CDX and where this maybe you can start with that status of CDX is, and then maybe that gives a good segue to the next step.
So CDX, where we are right now, we are focusing on defining two items. One is SAPI kit that would basically provide a digital descriptions of what the interfaces are and what their SI and PI requirements are. Right, so that should simplify a lot of the automation. Right, And our next thing that we are thinking about is a test design kit.
What design kit, David?
Test design kit.
Can you say it again? Steph, what is that?
Test. DFT.
Oh, DFT. Okay.
Right. Yeah.
Okay.
Right. How do you hook up the tests when you have the test pins when you have multiple chiplets? I'm not right. I'm not sure. That one is a little bit weird one in the sense that it's hard to do on a kind of for a demonstration purposes, right? Because test usually deals. You do some early planning for tests, but really the actual implementation and hook up tests kind of it depends on what test controllers are there and what protocols, right? And all the tools depend on having actual real data.
So
Right.
this is like the physical design DEF. Is that
No,
the depth you're talking about?
no, DFT, design for test.
Oh, DFT, design for test. Okay.
Yeah. Hooking up scan chains and what controllers are in each one, and these guys need to know what are the IOs, what is the timing between the IOs and stuff like that, right? And that requires a lot of real data. So that, and on one side, on the other side, we have not fully defined that. It's still up in the air. What is it exactly we need to define in CDX or CDXML even, right? Because anyway, standardization of tests happens in IEEE, right? And what we are trying to focus on is what information does a chiplet need to provide to enable the next level test integration, right? So there is we can capture that, but at this point we are not entirely clear what exactly does that mean.
I see. Yeah, test is actually a very broad topic, several standards into that. But outside of test also, there are several things, right? I think last time you were actually trying to define all the IOs and the connectivity and I think there was mention about SIPI requirements, electrical requirements.
Yes.
Right? That itself is a good, is that a part of CDX workflow, right? That
Yes.
I see. I think that itself is a good starting point, right? So
Yeah, that one is definitely a good starting point. That in and of itself is a very complex topic, but on the other hand, it's well contained within our domain. So it's a good point to attack, in my opinion.
yeah, so let's say if somebody were to provide a machine readable format instead of data sheet, and that defines the complete left views, and we can import it into the tools, right? That would be a very useful and highly productive thing, because we spend a lot of time in actually figuring out how the connections, where the orientation is, how to push.
Yeah. Yeah.
Right, and
Yeah.
all the connectivity, the verifying the connectivity is actually another painful thing, because this is actually, we have probably 20,000, 30,000 nets, right? And we are more than that. In if you're going for advanced packages, it'll be like 100,000 to 400 connections, connectivity, and it's impossible to manually look at each one by one.
That's right. Yeah, that's the zero order intent. There is that it's easy to define the connectivity and at least do zero order sanity check very quickly. Right.
And then the phi itself, right? Is it a by 16 phi or by 32 by 64? What is the phi, and that whole, I mean, these are things, information you can get from data sheets, right, or spreadsheets, but something if you can make that as a part of your spec and implement the flow, right?
Yeah.
You imported, let's say, a Deca type of substrate, and then you could place it, right?
Yes.
To creating a lot of manually creating each one of the views.
Right. Yeah. I know exactly what you mean. Yeah, that's the intent, to simplify that part. I heard that people are still using CSV spreadsheets to define substrate connectivity, and that's crazy thing to do in these days, right?
Yeah, maybe we should define a flow first. Hey, this is how we are thinking about the flow using the CDX specifications, the workflow, and then gather feedback to implement it. What do you think?
Okay. Yeah, that's fine too.
No, I'm wondering. Since I'm not actively involved in CDX, maybe I'm doing that already, or is it something?
Oh, yeah, I see. Yeah. We are definitely. So we have a workflow. That paper came out sometime last year, but that workflow paper did not necessarily address these. It was still it's whatever was available at the time. In terms of tooling, and it kind of captured the steps that need to be taken. But we definitely want to simplify the workflow. And what you mentioned in terms of connectivity and basic SI checks, these are going to come out of that, out of the SIPI kit, right?
I see.
Yeah, because the SIPI kit is going to tell us, hey, here's this interface, this is the speeds it can run on, here's the data pins, here's the clock pins, here's the skews which this interface expects, right? So with that kind of information, you can go and take a look at, hey, I have this other interface on the other side. Is it compatible? First of all, yes, right? Yes, no, and then I'm expecting that how these two would get, if it's compatible, how these two get connected would also be kind of the interface itself will provide that information, right? For example, if you're connecting UCA by 64 to UCA by 32, that the SI kit will have to tell us how exactly you can connect stuff, right? And then given the a possible package stackups, what is the combination that is going to work for SIPI that meets the requirements, right? If UC has requirements in terms of channels and losses, HBM has that, both does not, right? But at least, right, the zero order SI estimation can be done in that case. Tell you, hey, right, you place these too far, it's not going to work, or you place these too close, it's going to work, and here's the topology that's going to work.
So the spec is already developed, is it? That the CDX spec for the SIPI kit.
We are working on it right now.
I see. If you have any document, can you share?
We just captured in a PowerPoint the initial parameters that we want to code in CDXML for SIPI. So maybe in a few weeks, once we have those hashed out, I can share that with you.
Sure, that'd be great.
Yeah, yeah, and I actually not that I can, I will share it with you because I'm gonna be looking for your feedback too.
Yeah, I'll be more than happy to.
Yeah,
I do that day in and day out. So
yeah, our next order of business after SAPI is to describe a package DRM in a machine readable format.
Package what?
Package DRM. Design rule manual.
Okay.
Yeah, the design rule manual for the substrates to be able to describe it in a digital format.
Okay, that's very interesting. But
Yeah,
I don't think anything exists for Allegro APD or anybody who's using that.
yeah, probably not.
The values manually you have to go and.
Yep.
Although you can export the text file, it'd be good to have formal DRM.
Correct. I'm pretty sure in the DRM, we are gonna in the initial revision, the way I'm thinking about it is, we are gonna be able to capture the important parameters, right? Line space, thicknesses, materials are obviously going to be part of that. Stack up, right? How many layers? What are the thicknesses and so on, right? We are probably going to stop at things like any fiducial requirements, right? Any weird requirements such as can I place can degassing voids on two adjacent layers overlap or not, right? I think those are gonna become a little bit too complex to try to capture everything, right? You know, basically the DRM we can capture easily. The DFM is where it gets tricky.
I see. Currently, the substrate vendors or even PCB vendors, they don't provide such a text file or such a DRM. Like TSMC, they provided for the dies. It's very hard to get from these vendors. They just provide a PowerPoint or a rule book.
That's right.
Very hard to interpret. And last minute, I've been in many situations that at the time of tape out, we find something and then we'll have to go and fix, and that will be a huge turnaround.
I know what you mean. Yes, that's one of the things we want to avoid.
Maybe that itself is the first good starting point, because that's I see that is very useful for a lot of people, and I have a lot of vested interest in that as well.
Yeah, me too. Just the way we landed up, SIP kit comes in first, and that's going to necessitate the DRM description as well. So we are going to tackle, as soon as we get done with SIP kits over the next couple of months. Next, we're going to tackle the package DRM.
I see. Yeah. So I think that'll be good, David.
Yeah.
We can invite substrate folks to give feedback.
Yeah.
And that's actually something. It's a good, independent, well-defined work.
Yes. Yeah, it is. The it's going to be the challenge I see ahead of us in doing that is getting buy-in from all the EDA companies, because they all have their own little differences in how they describe their rules. Exactly, right? I expect a little bit of discussion around that. What is the way we're going to standardize in terms of how we measure things, right?
I see. No, if we get a buy-in from substrate vendors, they start offering it.
Yeah.
And then it'll drive the EDA vendors product.
Yeah.
Maybe you should do some little more research on substrate vendors. If they have any plans, probably their customers would also be asking for this, right?
Yeah.
Do they have any plans and what their thoughts are?
Yeah. Yeah, right. I'm sure that the customers would be happy to get something in digital form. the substrate vendors will probably be happy to provide it. The issue is when will the EDI companies support it, right?
I see. No, for now we could put a translator. Let's say I agree on a format that is easy to work with, and that could be a translation tool,
Yes.
and go from one vendor to the other.
Yep. That's probably one way it's gonna work. Yeah.
Yeah.
Okay,
Okay.
I like this discussion. Mark, do you have any thoughts about, those three things that I mentioned earlier? Which one would be of more relevance to the industry?
I'm sorry, I was temporarily distracted with another project. Sorry, what were the three items?
So we have been last several meetings, three thoughts have emerged. One is this golden chiplet prototyping, and the other one is this work that David and JP were talking about, which is primarily developing POC, but more in software as opposed to actually trying to tape it out. And the third one is die to die compatibility type of scheme, that design that JP was previously doing in the POC group. So the big question mark is, do we need to do all three, or maybe just focus on one or two? But
Yeah, I mean, so and again, I'm not familiar with the work that JP did together with Blue Cheetah in the past. I mean, I know there were some discussions on it. For just taking an outside perspective on it, I think, ultimately, I mean, people usually want to see it in silicon, and that's just a sort of unfortunate human nature thing, right? Like, you can simulate all day long, even digital circuits, right? Which really usually don't deviate between their simulation and their real life performance. People still want to see a test chip for stuff. So, as much as we can do, I mean, certainly software simulation is a step that is a good one, but in the end, I think people are going to want to see physical proof to really believe it. Like, and again, that's why we still have plug fests for PCIe and USB and stuff. Even if you simulate it, every different way that you possibly can, people still want to see it working. And there's a further advantage to having actual silicon is that if something does go wrong and you don't know why, then you've got something to go back to look at, okay, well, it works in this scenario, why isn't it working in the other scenario?
so I think, Mark, that is valid. We do run into this challenge. And by the way, that's exactly what we want to do. We want to build something. But we run into this challenge of, when we talk to folks like DECA or ASC or ATNS, their first reaction is, okay, this has to be a budgeted project. Otherwise, we cannot do the prototyping.
Yeah.
Right. So
And
somehow we have to.
Yeah, I think, Mark, what we are trying to do is actually a couple of things. On the software side, right? So doing project today has two sides to it, right? You will do the design step, which will do all the software, right? Integration. Somebody's going to have to sit down and do it, and then the next step is the actual manufacturing and testing, and validation. On the software side, what we are trying to do is make that process of design and simulation and planning a lot shorter, right? And kind of streamline it, ensure that it could be easier done. On the manufacturing side, right, and that software piece can be done, right, at least as a proof of concept, can be done relatively easy, right? Just if it's for demonstration purposes, right? It's a lot simpler to do. And if in the context of at least if there was a golden die, right, what we would still want to do is demonstrate a software that can ease and help with the integration of any other die with that golden die, right? And shorten the whole design cycle by a lot. Then the actual manufacturing of that is definitely something that will definitely have to be budgeted. Right. I guess, right. At least my hope is that right. If I was a bean counter and thinking about this whole project, I'm gonna say, oh man, I'm gonna spend 9 months of design cycle. How many resources I will need to actually get my physical good right before I can go into manufacturing. My hope is that showing that, hey, this design cycle, we can shorten the design cycle by a lot. If we can demonstrate that, then somebody who is thinking of manufacturing stuff could say, hey, you know what? I could not afford the design cycle before. Maybe I can afford it now and try to manufacture my little good just as a proof of concept that this stuff actually works. That's my naive hope here.
Yeah, so, one thing we should not completely drop, we have to figure out a way how to actually manufacture a physical proof of concept.
Yeah.
So historically, we ran into these challenges. Like, I tried quite a bit. It was only 100,000. And approached several companies. And the first question I get is, what is in it for us? Right? So to sponsor or be part of it. So this time around, I think if we were to go fundraising, we have to have some very clear thing which might be of interest to these folks who we asked for, joining the project or pitching in. Right. So,
Yeah.
I think,
Probably,
yeah.
Jawad, it would be one thought that I had is, yeah, if there is somebody who is already going to manufacture a test chip or test substrate on some of those new substrate technologies, maybe what if we have the software flow in place, demonstrate the benefit of that, and second is kind of get a little spot on the test shuttle with our implementation and show that that stuff actually works the same way as before, right?
So,
Yeah.
so go ahead. No.
Just we kept coming back around to the fact that everybody wants it, but nobody wants to pay for it.
Yeah.
Yeah. So we've faced this for last 5 years. Once in a while, we'd find a little bit, but what happened was every single time we are trying to tape out, right? And uh, one time that we were able to build the boards, the way it worked out was we have the tape out database ready. So we're not really asking anyone to pay us. with just saying, here is a GDS, this needs to be manufactured, and this is the bill. And then somebody jumps in and says, okay, fine, we'll pay for it. Right? So the method we used there was just have some faith that somebody will actually fund it. And let's just go do the design POC, and then we'll once we are at a point of manufacturing, then we'll deal with fundraising. So that worked out first time with the board, second time with the substrate. Somebody paid for the design, but nobody paid for the manufacturing. And I think part of the problem there, the demonstration would have been very specific to a couple of companies, right? It was Blue Cheetah and D Matrix. And if those two companies are not stepping up, then I'm not sure if somebody else will, right? So maybe one way to think about it is, if we can define a POC project that we think potentially would be of interest to some other, a broader audience, right?
Mhm.
Yeah, maybe, hey, if you're building a chiplet test chip, let's work together on that, right? And see what could be done, something like that.
So we had this idea about the golden chiplet sitting in the middle. Did that come with the concept of a standardized test chip IO pins or something?
Sorry, Joa, say this again.
So let's say if I'm a Phi developer, is there, I make my own test chip just for testing it myself, but if I want to test with others, is there some kind of a specification available that I can use for my test chip that I can do interop with somebody else?
iOS, there is a spec, like you say EBOW, right? But
Yeah.
test chip itself, there isn't any spec that's left to the implementer. That is really a challenge if to test the interoperability. Everybody has got their own die construction,
Mm-hmm.
and there isn't any standard I'm aware of.
And the big question is, does it even make sense to try to standardize it?
Actually, for test chips, it makes sense, right? Depends on, then it actually also depends on technology. There are too many variables. Standardization is challenging,
Mm-hmm.
but it'll be good to have some kind of socket definition for the chiplet, right? Just like we have the Intel CPU sockets, we have a chiplet socket definition so that we can test in the same way. Right, prove the interoperability in the same way.
Okay.
Yeah, I think we need some more discussion on this. Let's think through this idea about the chiplet sockets and see if it makes sense. And another thing is actually the DRM for substrates and the automation flow around that is also a good idea. So let's think through this couple of ideas. And golden chiplet, we need to touch base with Kash if he has made any progress or anything, any updates from him.
Yeah. So I think we should probably ask Kash to drive it. And the thing where we can potentially provide support for that effort is defining, how other people connect with that.
Correct, exactly.
So that could be one. Regarding building using our CDX flow, building actually a demonstration system with the hopes of somebody will manufacture it is quite valid. And but JP, we need to take one step back. We need to
Mhm.
look at the industry problem. So interoperability is a problem that we've been trying to solve. Then obviously, the manufacturability is a big challenge because this, after seeing a lot of these manufacturers, only seems like if TSMC is the only one in volume production of these advanced packages. But there is really not much we can do there, right? There's a new theme that has been emerging lately, and there's very little thought around it, and that is 3D IC, that chip silicon on silicon. And access to that technology is just next to impossible because purely TSMC, but maybe that's another thing to think through if there is something that can be demonstrated on 3D IC using purely the software implementation of it.
By
Yeah,
the way,
another challenge with 3D is really thermals.
Yeah,
So
I was gonna make the same comment.
yeah.
speaking of
Yeah,
speaking,
Jawad, Mark, I need to drop off now, but I'll sync up with you next week. We'll think through this a little more.
Okay, JP,
Yeah, sorry about that. Thank you.
no worries.
Yeah,
So
bye.
yeah. By the way,
let's just finish this thought. David, go ahead.
yeah, no, I was going to say, speaking of a golden chiplet,
Mhm.
at the last chiplet summit, there was a company right next to Acronix. They licensed their FPGA IP, and their plan was to make a FPGA chiplet with die-to-die interface. That's another option, right? To have a golden chiplet, right?
But David, it wasn't that very similar to what Kash was showing?
I'm not sure. They didn't have the die-to-die chiplet yet. Probably it was. I don't remember exactly the block diagram. Might be worth to track them down and see what they have and how similar it is to what Cash was proposing.
Okay.
Right. It's always good to have a couple of different venues to get the same. If we can get the same chiplet.
Yeah.
And they are a startup, so they may appreciate a little bit of help on the design side, right? To collaborate,
Okay.
right? Startups never have enough money to spend, so they may appreciate a little bit of help, whether it's the design or the expertise. If they're trying to tape out and thinking how do we design the substrate for this, we can demonstrate the CDX workflow on that itself.
Yeah. Okay. I guess we can have maybe another meeting on this topic where we need to figure out a direction of what will be more compelling that we should spend our energy on, and that where we can get more people who would be interested in participating.
Yep, agree.
Okay. Any thoughts, Mark? Otherwise, I think we can wrap up.
No, nothing to add from me.
Okay.
All right.
So
We'll talk again next week then.
thank you.
Thanks.
All right, thanks.